So we got this question that we need to solve, and you can see clearly that grade 1 is applicable to what we have on top here, and between those two mass, those two mass, then we're gonna get y1 here and y2 this side. So we're gonna go with the same principle. We're going to solve it according to the mass. You're gonna take everything connected to the mass and move it. So we're gonna have two equations. This is the first one. I'm gonna paste it here. This is the first equation. And not to forget, this is where we have y2. Okay, and y1 was somewhere there. And for the second equation, we're going to take this block. Okay, so I'm gonna paste it here. So this is what you're gonna get for, and remember this is where we have y1. So these are how I've break it down. So you take everything connected to the mass, you move it there aside, and you break it down so then you can solve and get all the equation. And look here, we do have ft, so meaning it's gonna be f of t equal, we start with the mass, it's gonna be m1 d square. This is how we represent this block. It's gonna be y1 of t. Okay, so this y1, this time working with y instead of x, plus I'm going to add, so ft will be equal to the sum of this one plus this and plus that one. So, and pay attention, note that everything on top is based on y1, so even this side it's y1. Okay, so y1 it's everything that you see at the top. Okay, then we're going to get this equation as it is, and it's it's gonna be k k1 y1 of t plus b, it's gonna be the first derivative dt y1 of t. Okay, then plus k2, and k2 will be, you're gonna put a probability to the one that is close to the mass, so it's gonna be y1 negative y2. Okay, and there is a nice way to represent this, so I'm going just to add function of t minus y2 function of t. So this is what you're gonna get on the equation of the first block. So this is what we get on the first equation when we're solving this equation. So then let's write the second equation now, so then you can see. I think I'm gonna just for me to get some space, I will convert them into S domain so that you can see. Let's just move this on the side so then I can have space to write down. Okay, now this one, since there is no ft is it's actually connected to m1, so that means we're going to write 0 instead of ft. It's going to be 0 equal m2 d square dt square. Okay, and this one's going to be m2 of t plus this k2, and k2 it's going to be the one close to the mass is gonna have a priority. It's gonna be y2 minus, so I like putting functionality minus y1 of t. So this is what we're going to have in the second equation, and I'm going to convert into S domain, and we're going to assume that our initial condition equal to 0. So I'm going to assume that the initial condition it's equal to 0. Okay, so we're going to take the Laplace transform. So we're going to apply Laplace transform in order to convert from to S domain. So now we're going to get something like this. I'm gonna just go straight and give you, it's gonna be in capital M1 A square Y1 of S plus K1 Y1 is plus B S Y1 of S plus K2 Y1 of S minus Y2 of S. So this is what you're gonna get from that equation. And if you have to take just for you to see, okay, let's take now the Laplace transform on this other equation. So we're gonna get 0 equal to S square. I'm going to assume that the initial condition equal to 0 plus K Y2 minus Y1 S. So this is what you get after applying, you get in S domain. Okay, this is it. This is how we go about solving this question. So this one's gonna be equation 1 and this one equation 2. So you're gonna take them and solve further. If your question is you're asked to solve for y2 or y1, depending on how you're going to do, you can just swap the equation around and solve them.